Okay, so this is lesson 111. Almost there, guys. Applications using division. So like real life stuff when you'd really use division. Um, so example one gives you a situation where you have 100 kids and you want to put them in 3 classrooms. They don't want like 99 kids in one room and one kid in another room and one room's empty. They want them as close as they can. So we're going to take our 100 students and divide it into 3. So 3 goes into 100. My answer is going to be 33 and 1/3 kids. So we assume that we're going to not chop anybody up. We want whole kids, right? They would probably get mad if we start chopping kids up. So I drew and I love pictures on these. I drew myself 3 little classrooms and I put 33 kids in each room, right? Well, I would put 33 and 1/3, but I can't chop anybody up. So I'm going to take my extra kids. So that's 33 plus 33 plus 33 is 99, but I had 100. So I'm just going to put my extra kid in one of the classrooms, and that class just has 34 kids. It really helps to draw a picture on these, and it looks silly, and you see my pictures are not elaborate, but it really does help if you start struggling with this stuff. Sometimes it's hard to imagine that 1/3 being a kid. Okay. Example 2, this is movie theaters. So movie theaters are $8. Jim has $30. So how many tickets can he buy? So again, I'm doing division. So 30 divided by 8, I get 3 6/8, which turns into 3 3/4. So he can buy 3 tickets for sure. Can he buy 3/4 of a ticket? No. Maybe he has leftover money for popcorn or something. He can only buy 3 tickets. He does not have enough money for 4 tickets. Tickets don't come in half increments or 3/4 increments. So in this case, you have to round down to say, oh, he can only buy 3 tickets. Example 3. A little bit different. It says 15 children need a ride to the fair. Each car can transport 4 children. How many cars are needed to transport 15 children? So I drew myself some cars. And again, my drawings are not elaborate. So I put 4 kids in that car, 4 kids in that car, 4 kids in that car. So I know that's 12 kids. I have 15, so only 3 have to go in that car, right? You can do the division and you see that you get 3 kids in each car and then you have a leftover part of a kid, right? So you're going to divide those extra 3 this way. So that car is only 3/4 full, if you think of it that way. Again, I like pictures because I feel like you can really see it. I feel like otherwise sometimes you get tangled up. Maybe it's just me. Okay, example 4. This is where Dale is building something. He has a board, and his board is 10 feet long, and he cut it into 4 pieces. So how long is each piece? So I cut my board in half. I said each one is 5 feet, and then I cut it in half again and said each of those is 2.5. I can also say 10 divided by 4, and I get 2.5, so I know each piece is 2.5 feet long. Again, love my pictures. You don't have to. You could probably tell from that each piece would be 2.5. This is kind of like a good way of double checking that you're on the right track. Example 5 was a swimmer, and she was a swimmer, and these are her times. So these are all in seconds. And so they ask us to find the mean, which means the average. So I'm going to add them up and divide by 3. So I'm going to find, if I have those 3 times, what's her average time? So I add them up, came up with this 111 6/100. So I divide by 3. There's some tricky zeros in there, so make sure you get that part right. Double check your answer, and you get 37.02 or 37 200 second was her average time. So that's another instance where you'd use real life division problems. I took a look at the practice set, and I'm not going to do this one for you. But I did want to mention, again, this is when I'd use pictures. So you have 90 kids, you break them into 4 classes. So you do your division, but don't chop any kids up, okay? It won't be the same amount in each class necessarily, but it should be close. You don't want to have 70, 10, 10, and 0, right? So you want them to be as close as you can. Good luck on this. I think you'll do fine. So 2 more lessons and we're good.